7.3, page 1, hypothesis testing for the mean when population standard deviation is unknown. Okay, there we go. Our very first page. (7.3) Hypothesis testing for the mean standard deviation is unknown. Guidelines. We need to find the critical values using a t-distribution. How do we find that? First, we specify the level of significance or alpha. 2, we identify the degrees of freedom, which is defined as degrees of freedom equal to n minus 1. Step 3, find the critical value or critical values using t-distribution table that we used before to form our confidence interval. Remember that when we used it for confidence interval, we had level of confidence C. Now that we are working with hypothesis testing, we have to use alpha. So we need to forget about level of confidence for hypothesis testing. So we're going to just shade this part. We're not going to use the level of confidence because we are working with hypothesis testing and now we are dealing with alpha.
But I have a question about when
H sub 0, it says mu is greater than or equals to k. Your alternative hypothesis was mu less than k. So mu less than k, we get a left-tailed graph, left-tailed test. Right-tailed test, we had, here we go. Null hypothesis says mu is less than equals to k, and alternative hypothesis says mu is greater than k. Right-tailed test, and finally we had a two-tailed test. Your null hypothesis says mu is the same as k. Alternative hypothesis says mu is not k. So either on the left-hand side or on the right-hand side. So based on the category that we have, we find the critical value. If we have a left-tailed test, then we use one tail alpha. One tail alpha. And since our critical value is on the left-hand side of 0, it is a negative number. So we put a negative sign next to the number that we find using our t-table. If you have a right tail test, then Just look at the table. Define alpha and the degrees of freedom, the intersection between them gives you your critical value. It is positive. Why is that? Because it's on the right-hand side of 0. To the right, it is positive. And finally, if we have a two-tailed test, we're going to use two tails alpha. And then we find the degrees of freedom, we find the intersection between them, and note that it's a two-tailed test. It means that you have two critical values. One of them is on the left-hand side of 0 with negative sign. The other one is on the right-hand side of 0 with positive sign. So both of them, they have the exact same digit with different signs. Our example says, well, finding a critical value for a left-tailed test. Left-tailed. Left-tailed. This is our left-tailed test. It means that the critical value must be negative. Critical value is negative. So for sure you get a negative value. Let's see what information are given to us. Find the critical value t sub 0, which is negative, of course, for a left-tailed test when alpha, or level of significance, is 5% and n, or the sample size, is 21. Let's take a look at the instruction. What information do we have and what should we do? First, specify the level of significance. Well, I have it. It's just right here, 5%. Identify the degrees of freedom. I don't have this number, but I know degrees of freedom is equal to n minus 1. The sample size minus 1. So we subtract 1 from n. Degrees of freedom is n minus 1. So the degrees of freedom is 21 minus 1, or the degrees of freedom is just 20. Well, okay. And I know that I have a left-tailed test. Left-tailed. This is given in the question to me. I have a left-tailed test. Very well. It's left-tailed. I need to use one tail alpha because it's left-tailed. And let's find that it is 5%. So 5%, just right here, 5%. And the degrees of freedom is 20. Here we go, 20. Where is 20? 20 is just right here. So let us find the intersection between them. Intersection between 20 and 5%. As you can see, the intersection is 1.725, and t sub 0 must be negative. So I put a negative sign in front of it, 1.725. Okay, so what's the meaning of that? What does it mean? It means that if I graph using a normal distribution. We know that t-distribution gets closer and closer to normal distribution as the sample size increases. My t sub 0 or critical value negative 1.725, which is roughly here. Divide this graph into two pieces. So this is my t sub 0. On the left hand side, I get my rejection area, rejection region. So this is my rejection region. And on the right hand side, I have non-rejection area. If T lands here, it means that I need to reject the null hypothesis, meaning the rejection region is on the left, the green area to the left, and if my T, which is x bar minus mu divided by s times square root of n, is in this region, in this green region, then we have to reject the null hypothesis. That's the meaning of that. So I'm going to put this one away. I'm going to keep this one so you can see and you can compare. We are on page 2. Another example. This example says, find critical value for a right tail test. Okay, so now we are moving on to a right tailed test. Note that since it's a right tail test, your critical value is positive. So quickly write it down. Critical value is positive. It means that after finding the critical value using the table, you don't have to make any changes. You just copy this guy down here. Let us read this. Find the critical value t sub 0, which is positive, for a right tail test with level of significance alpha equals to 1%. Okay, 1%. And the sample size is 17. So level of significance is given, and my sample size is also given. So let us take a look at our instruction. Here we go. Specify the level of significance is given 1%. Degrees of freedom. Well, I have my sample size, so I can quickly find the degrees of freedom, which is subtracting 1 from the sample size. So the degrees of freedom, which is 17 minus 1, equals to 16. The degrees of freedom. Very well. The question says I have a right tail test. It means that I just find the intersection between my alpha and the degrees of freedom, and I copy down the critical value here. So let us start. So my alpha is equal to 1%. And it's a one-tailed test. It's a right-tailed test. So I'm just going to focus on the first row for alpha, 1%, which is just right here. And the degrees of freedom is given as 16. 16, let us find 16 here. 16 is here. So what's the intersection between them? The intersection is 2.583. Well, we found the critical value. We write T sub 0 or critical value equals to 2.583. So what's the meaning of this critical value? Meaning of that? It means that this critical value, this number, separates the rejection region from the non-rejection region. So 2.583, which is very close to 3, in the middle, almost in the middle. It means that, okay, my rejection region is a very small, this green region is a very small region on the right-hand side. I already know that it's a right-tailed test. So the rejection region is on the right-hand side. The rejection region. And here I have my T sub 0, which is 2.583. So it means that if T, standardized test statistic, x bar minus mean divided by s times square root of n is in this green region, then we reject the null hypothesis. If not, we fail to reject the null hypothesis. Thank you, Vanessa. Elaine, thank you. Dora, thank you. Okay, perfect. Now, interesting part is having a two-tailed test. Very well. Finding critical values for a two-tailed test. Two-tailed. Okay. Let's take a look at our two-tailed test. Remember that you get two critical values. One part of that green area is on the left-hand side. The other part, the exact same area, is on the right-hand side. Well, here we go. So what information are given to us? Find the critical values minus and plus T sub 0 for a two-tailed test when alpha is 10% and your sample size is 26. Two critical values. Level of significance is given to us and the sample size is 26. So what do we need? Since we are using a T table, we need to find the degrees of freedom. The degrees of freedom, n minus 1 is 25. Take a look at your table. Let me use a new table since I only have two colors. Okay. Remember that if you take a look at a T distribution, the first row is level of significance that we used for confidence interval. For hypothesis testing, we're focusing on alpha. Here we have a two-tailed test, two tails, alpha. So we have to focus on the second row for alpha. Alpha is 10%. 10% is just right here. So, okay, let me just highlight this guy. 10%, and the degrees of freedom is 25. So just right here. Let us find the intersection between them. Intersection. It gives us 1.708. 1.708. Okay. This is positive. What should I do now? Remember that the digits are the same, the signs are different. You get a minus 1.708 and plus 1.708. Two critical values, negative t sub 0 and positive t sub 0. Well, what's the meaning of that? It means that if I graph this using a two-tailed graph, I have the following result. Negative 1.708, okay, roughly here, and positive 1.708, which is here. So minus t sub 0 plus t sub 0. A part of this green region, rejection region, is on the left. Another part of it is on the right-hand side. So both of these count as rejection region. Rejection region on the left and rejection region on the right. Region on the right. Okay, perfect. So what's the meaning of that? It means that if the most important part, meaning if t, which is equal to, we're going to calculate this later, x bar minus mu divided by s times square root of n is in either of green areas, then we reject the null hypothesis. If your t is less than negative t sub 0 or greater than t sub 0, we reject the null hypothesis. So first of all, we have to check to see if our population is normal or n is greater than equals to 30. Then, of course, we have to specify if we have a left-tailed graph, right-tailed graph, two-tailed graph. Those are stay the same. In the third step, when sigma is not given, we find alpha, we find degrees of freedom. We use our t-table to find critical values, the thing that we exactly did. After finding critical values, we have to find t, x bar minus mu divided by s times square root of n, which is standardized test statistic, and check to see if t is inside that green rejection region or not. If it is, we reject the null hypothesis. Otherwise, we fail to reject the null hypothesis. Let us go over examples to feel more comfortable about this. So page 4. Example. Hypothesis testing using a rejection region. Let us read this carefully. You know that we stop at each number and we try to analyze that number. A used car dealer says that the mean price of a 2-year-old sedan in a good condition is at least, okay, we found the first keyword, at least. So how do we interpret at least? What is the mathematical symbol that we use for at least? What is the mathematical symbol that we use for at least?
Less than equal.
Less than or equal to.
Is it less than equal? Is this greater than equal? Which one is that? At least. So your GPA must be at least 3 for admission.
Oh, greater than equal to.
Greater than or equal to. Excellent. Excellent. So it means that greater than or equal to. So tell me this. What is given to you? Is it your null hypothesis or alternative hypothesis? What's given with at least? Which category is this? Greater than or equal to, which one was that?
First category.
First category. Thank you, Adlan. Thank you so much. So let us write this down here. Your first category is given. This is at least greater than or equal to. Because of equality, we have our null hypothesis. It says mean is greater than or equal to $20,500. So it means that we can quickly write our alternative hypothesis. Mean is less than 20,500. So you suspect this claim is incorrect and find that a random sample of 14. So what is 14? Is it X bar? Is it? Okay, thank you. Thank you very much. N, or the sample size, is 14. Similar vehicles has a mean price of 19,850. What is this number?
X bar.
X bar. The rest of the class, what is this number?
X bar.
X bar. Very good. Thank you very much. This is your sample size, which is 19,850. And standard deviation of 1,084. What is this number? It says the standard deviation. Is it sigma or is it S?
Sigma.
Sigma.
S.
S. Very good. Sigma is about population. Read it one more time. It says, okay, you find that a random sample. These information are coming from your sample. A random sample of 19 has a mean and standard deviation. So standard deviation 1,084 is your S. Sample standard deviation. Sample ST. So now, is there enough evidence to reject the claim at level of significance is also given to us? 5%? Okay, we're happy about that. Assume the population is normally distributed, so I'm not worried about the small sample size. Well, let us go to the board, start solving this. page 4, example. So, first of all, tell me this. Are we following the first one or the second one? Which one we're following? Are we using Z or you're using T? Which one?
T.
We don't
T.
have this.
Why is that? Because we don't have
Animal.
sigma. We don't have the population standard deviation. What we have our sample standard deviation. So we're not going to use Z. We're going to just focus on our T. Okay. So let's write down the first step, and is greater than or equals to 30 for population is normal. Okay, perfect. And the second step is to identify the type of hypothesis that we have. Then 3, finding the critical values, alpha, degrees of freedom, n-1, and t sub 0. And step 4, we need to find out standardized statistic, t, x bar minus mu divided by s times square root of n, and 5, if t is in the green region or rejection area, then we reject the null hypothesis. Otherwise, we fail to reject. Let's see. So, what is our n? Step 1. N is equal to
14.
14. Very good. The rest of the class. What is our n?
14.
14. Perfect.
14.
Thank you. Thank you so much. 14. So as you can see, 14 is not greater than equals to 30. But in the example, in the last line, we know that the population is normally distributed. But population is normal. Okay. 2. Null hypothesis, alternative hypothesis. What is the null hypothesis? What is the alternative hypothesis? And is it left-hand? Is it right-hand? Which one is that?
Left.
Left-hand, very good. The rest of the class? Left, very good. Thank you. Thank you.
Left.
Left, thank you. So our null hypothesis is mu. The mean of the population is greater than or equal to $20,500, and its opposite, the complement, says mu is less than $20,500. It means that, remember that, we look at the alternative hypothesis to distinguish between different graphs. This is a left-tailed graph. Left-tailed. It means that the rejection region, the green region, is on the left-hand side. Rejection area. But we don't know what critical value is. So in our next step, we need to find the alpha, degrees of freedom, and the critical values. Okay, it's not that hard. You already know that alpha is given to us as, what is our alpha?
0.05.
5%, thank you very much. 5%. And I already know n is 14, so the degrees of freedom is equal to 14 minus 1 or 13. Excellent. And this is a left-hand graph. Okay. Let's take a look at our T-table. my alpha, 5%, and it's a left tailed, okay, 5%, one tail, so I'm looking at 5%, and the degrees of freedom, 14 minus 1, which is 13, okay. The intersection between them is 1.771. 1.771. Is it negative or positive?
Negative.
Negative.
Negative. Excellent. It's on the left-hand side of 0. Your 0 is in the middle. On the left-hand side of 0, you get negative 1.771. Well done, everyone. Well done. So what is the next step? Step 4, we need to find our standardized test statistic. 4, t is equal to x bar minus mu divided by s times square root of n. What is x bar? Our x bar is equal to
$19,850.
perfect. Perfect. The rest of the class, x bar
985.
Okay, thank you. Thank you so much. Thank you, Emily. Thank you, Edgar. Thank you, Elaine. Thank you. So 19,850 minus the mean, which is 20,500 divided by S. What is S? Sample standard deviation. It's given to us. Thank you, Olivia. Very good. Thank you, Elaine. Excellent. S, 1,084 times square root of n. N is 14. Please use your calculator. Give me the value for your standardized test statistic. We get an approximation. What do we have? Negative 2.244, okay. Negative 2.4, okay. Okay, perfect. The rest of the class, Jessica, thank you. Emily, thank you. Avalon, perfect. Thank you, Fabiana. Thank you, Olivia, perfect. Approximately negative 2.44. Okay, so just one step left. 5. Is T, is this number inside the green region or not? Is T, which is approximately negative 2.44, is in the green area? Should we reject the null hypothesis? Yes or no? What do you think? Negative 2 is less than negative 1.7. It's on the left side of your critical value. Since minus 2.44 is less than minus 1.77, I can just write down 771. So we reject the null hypothesis.